software. So about the agenda, the session will prepare you for the basic statistical methods for quantitative analysis and descriptive statistical methods and their appropriate usage, translating an application hypothesis to the statistical hypothesis, using appropriate hypothesis testing and making sense of the outcomes for interpretation and application to the real life problems. And lastly, it will talk about the basic regression analysis, hands-on practice, and R software.
Okay. Thank you so very much, Gohar, for such a nice introduction. Can you hear me? Hello?
Yes, ma'am, loud and clear.
Okay, fine. So I would like to share my screen now. Can you please stop sharing it? Yes, everyone here in this session, Assalamu alaikum and welcome all, my dear respondent. So I found some comments. Certainly, I tried to finish. It's not an easy task for me as well and you to understand all such statistical So I would like to finish it up within prescribed time. The agenda which I have in my mind, how to do it is, firstly, I would like to discuss the slides which you have already with you, and the recorded session as well, you have it. Then after that, I would like to respond the questions already I received, and then the question answer session. So I think so there is some problem. Can you please check it out here? That's it, fine. But I can't see myself over here. Okay, anyhow. So my dear participants, this is the basic statistics, and further we will hands-on practice on the R for the basic regression as well. I'm not claiming that this is the all what you have to do. You can do much more things, but at least these things you have to do. Like, I will start with the definition. There are so many comprehensive definition of statistics. I'm pretty sure you have an idea about that, but I want to be very simple and precise and targeted to the things which has to be fruitful for the non-statisticians. So statistics is they convert the data into information. The main essence is over here is the data. And data can be bifurcated. Statistics knows each and everything. It knows the science of data, you can say. So it's all about data, right? So data can be bifurcated into qualitative as well as quantitative aspects. So the qualitative, furthermore, is bifurcated for the nominal and the ordinal, as well as the quantitative for the continuous and discrete. I know there is a streams of the ratio and interval. It's the same thing, my dear. So I would like to be very simple that everybody can understand. So qualitative, I said it's meant for nominal and ordinal, and basically it's a categorical. Like categorical means and nominal mean. When you have the categories, the simple daily life example is the gender. I am coming to the class and I would like to see how many females and males over here in my class. So I can write down it's males and females, just to the heading for the male and female. So it's irrespective, or there's no order matter if I will write the female first or the male first, but I have to write them into at least two categories. I will make two categories for them. So these two categories, the categorical data, when order does not matter, it seems to be nominal. I think so it's clear now. Ordinal meant for when there is particular order matters. Like being a teacher, I can say the grades of the students. You see, the A+, the student who got A+, it must be at a higher level than rest of the class. Then it's going to be A, then A-, then B+, B, B-, and so on. So there is a particular order in that. I cannot be bifurcate that order. Then it's known to be the ordinal data. Or the 5 Likert scale we usually use in the social sciences. For example, from the highly dissatisfied to the highly satisfied phenomenon, highly dissatisfied, neutral, satisfied, and highly satisfied. So these meant for qualitative ordinal. And I'm quite sure you have an idea about the discrete and continuous, but in a very quick response, I would like to say discrete meant for whole number values, number of students, number of petals, number of chairs, number of siblings, like that, which cannot be into the decimal. And then the second one is the continuous. Continuous is meant for continuity, which can take each and every value within the given interval. Then it's for from minus infinity to plus infinity, you can say, like the heights, weights, temperature. These are all prices, age. It's all to be the quantitative continuous variable. So what you can do with this data when you have qualitative, quantitative, and nominal, ordinal, blah, blah, blah. At least you can do the univariate, bivariate, and multivariate analysis for such a data. What is meant for univariate? Uni stands for one. One variable when you take into consideration either graphically or numerically, you would like to represent your data, then it is known as the univariate analysis. Single variable analysis, dealing with the single variable graphically or numerically, is known as to be the univariate analysis, knows to be like pie chart, bar chart, histogram, etc. Then there is a question when to make the pie chart or bar chart and histogram. For the qualitative variables, usually you go for the pie and bar, and for the quantitative, you usually go for histogram and histogram. It's a time series data analysis. And if you want the numerical observation for that, then you can calculate its mean, median, mode, dramatic mean, harmonic mean. These are known as cumulatively the averages. The quantiles are quartile, deciles, percentiles, the positional values usually used into the competitive exam, you see. Then you need to check its variability, like variance, standard deviation. These all report you the single value for corresponding variable. So this is known as the univariate analysis. Now let's go for the bivariate. Is it fine? Are you with me? Listening? Hello, dear participants. Now, the bivariate analysis. Bivariate is known for two variables simultaneously you would like to study it out. So again, there is a question when you have two quantitative variables. I told you quantitative, discrete, continuous. So rigidly, you can say when you have the quantitative variables, then you need to apply the Pearson product movement correlation. Simple correlation. Usually a layman stands for correlation. The relationship or strength of association between two quantitative variables can be assessed through Pearson correlation moment formula. Then when you have the qualitative variable like nominal to nominal, nominal to ordinal, what to do? You can use the chi-square association test. And I want to clear one query here as well. I received. Then what will happen when you have a categorical variable and a continuous variable? So my dear, continuous quantitative, just refer here when you make it categories, like you have the age of the respondent and the gender. In the qualitative aspect, we have taken the gender, and in quantitative aspect, we have taken the age. But you need to make the categories for age. The chi-square correlation is just work for the categorical data. Fine. So you have to make the categories even for your continuous or discrete data. Then it will work. Otherwise, there is a special correlation. It's known to be the point by serial correlation, which is also is as equivalent to the Pearson, and it's work in both SPSS, and you can go for R. You can calculate your point by serial correlation. I think now it's clear. Somebody was curious how we can calculate the chi-square for the qualitative and quantitative. So my dear, whenever you have the quantitative variable, then again you need to make its category. Then you can calculate its chi-square. Otherwise, no. Then there's a question when we have the rest is meant for ordinal. Ordinal stands for when there is a particular order, like I told you the rank of the students. A plus, A minus, like this, and the satisfaction level. These are both ordinal variable. When you have two ordinal variable, then you have to go for Spearman rank correlation. And these are the built-in function into the R and SPSS. You do not need to worry about it. How to get it on one click, even you can get it. Okay, then there is in the bivariate analysis, the simple linear regression model also comes. This is the aspect when you have no idea which variable is going to be, you say, dependent and which variable is going to be independent. For example, you would like to assess the relationship between the marks of the student and time spent to the study. Here you have a clear idea that the marks of the student are certainly depend on so many things, but at least it's depend on how much time he or she spent for the studies. So when you have a clear idea and you would like to go for bivariate analysis, then it's better to apply regression analysis, the equation which you can see it here. Here, Y stands for your response variable. Like in my example, this is the marks of the student. Beta is the slope, not the slope. It is the intercept where the line cut is the y-axis. Fine, it's having no x values. So this is beta 1 is going to be the slope. Okay. Now, just wait a minute, please. Okay, sorry for the interruption, my dear. Now, the simple linear regression, I told you, you need to apply when you have a clear-cut idea about the dependent and independent variable. Because in correlation sort of things, you do not need to worry about the dependent and independent variable. Even though for the nonsense variable, like the number of mosques and number of crimes, you can check the relationship. There is a nonsense relationship. When the number of mosques increases, the number of crime increases, it is nothing is going with that. But I just meant for that, you can check the correlation for even to any variables. But for the regression analysis, at least you have to go for the dependent and independent variable. Now, it is a response variable, and this is the independent variable. Marks of, this is the marks, and this is the time spent to the study. Now, firstly, go for the hypothesis testing. I would like to be hands-on for R, as I promised. So I'll go for the R console. Most probably you too have it. Their same names. This is the interface of the RStudio, and this is the input. This is the output window. Here you can display your variables, and here you can see the packages and graphical representation. So here we meant for the independent and dependent variable. X stands for your independent variable, Y stands for your dependent variable. So already I have the data set into over here. Just you need to put the data and run it. What to do? Then you can check its correlation as well. This is the same for the Pearson product moment correlation. It's by default built-in function over there. When you write up COR for XY, it will just calculate the correlation between the two variables. And you can see the output here. How much they are related. Look at here. It's going to be 0.9577. It's a very good positive correlation between the two variables because they are highly correlated. This is the data you remember. You have seen into my slides, which I have given already prior to the session. That is for the yield and the fertilizer. So yield is depending on the fertilizer. So it is sensible relationship over here. When the yield increasing, the obviously fertilizer increasing, the yield will also be increased. Then the second, we can check its plot. We said this is the simple linearity now can be checked through this plot. Here you can see. As the data set is quite small, but there is a majority of the point out of, you can say 1, 2, 3, 4, 5, 6 points. 5 are in line in a linear manner, in a linear relation. So we can go for that. Is it? Now you can put the regression line on that. You can put the, see the trend line and the summary statistics. What the summary told you, dear participants, the summary told you like about its, you see, this is the estimated value, means your coefficients, beta values. This is the intercept, beta naught hat, and this is your beta 1 hat value. What does it mean? It's meant for that with a unit increase into the independent variable. What was the independent variable you have it here? Fertilizer. The response variable will be increased by 0.49933 value. And it is going to be highly significant. You see the p value. The two important column here in the summary statistics is the estimates and the probability. You need to concern for that. It's going to be 0.0000 going on to be so many zeros. It's 14, 0 after the decimal point, and then you have the value 5. What means to be, it is quite highly significant for explaining your response variable. Now I will quickly go for multivariate. When it's to be the multivariate analysis, my dear, when you have more and more independent variable. As I told you, now you can do simple univariate analysis, bivariate analysis, and multivariate analysis. Rather than it's a bivariate is left it for the hypothesis, I will go again for that. But as I am in the stream of simple linear regression, so I will go for multiple simultaneously. Now, it was suggested that when you have more and more independent variable, then you need to apply the multiple linear regression model. You have to store your variables with their specific name. Here is the sale price, land value, improvement value, area, and the sale price is depending on land value, improvement value, and area. What it's meant for? This is our Y, response variable. This is our first explanatory variable, second explanatory variable, and the third explanatory variable. Means simple to the independent variable. I have already stored the data over here. So I'll just run it. This blue meant for everything is going fine. And now what is the syntax for that? You are putting the linear model, but now the multiple linear model. So LM, the same command you use for simple linear here. This is your response variable. It still stands for the response variable is based on the first explanatory variable plus second explanatory variable plus third explanatory variables. Now we would like to run it. This will give us the multiple linear regression model, and we will see its summary as well. Here, what the summary suggests to you now. These are the betas value. Beta, it is beta naught hat, beta 1 hat, beta 2 hat, beta 3 hat. Why we get these three values? Certainly we have three independent variables, so we get these three values, and this value stands for the intercept. So intercept are having no much important. It's the baseline value, and the most important things needs to be explained here. These independent variables with respect to their corresponding probabilities. When you have that, what is the criteria? The criteria is that you have to observe that these p values has to be what? Lesser than the 0.05. If the p value is lesser than the 0.05, then that variable, corresponding variable, you see the stars over here, and the corresponding variable is the improvement value. These explanatory variable, or simple words, my independent variable, are very much fruitful in order to explain your response variable, which is the price. Now you can see land value as well as the area, because it's also you can consider to be the higher than the 0.05 when you round it up. It's going to be 0.06. Not much higher, but certainly we need to reject it. Fine. But what you can do, either to reject both simultaneously, you can go for eliminate the least important variable. This seems to be the least important independent variable, which is the land value. Why so? Because it's having your probability, this probability for the p-value is larger than the 0.05. So we can make a new fit, or that sale price is now dependent on improvement value and the area. Now we need to run it. Okay, and then we can see its summary bit one. It's over there. Look at here. It's improved a lot. It was already significant, and it's also improved, which was priorly for, look at here, 0.05, but now it's 0.02. It's meant for that. It's explaining for maybe the multicollinearity here. Multicollinearity is another important aspect, that there is a correlation between the two independent variables. My dear, you need to certainly read out in depth the assumptions to apply the simple linear regression model as well as multiple. The core assumption is that the response variable has to be normally distributed, and there is a relationship between the independent and dependent variable. But there shouldn't be the relationship between the two independent variables. Like you can see, we can most precisely interpret that most probably there is a relationship between these two variables as explaining the same thing. So that's why they are collinear. And now when we eliminate one variable who's having the highest p-value, then we need to get the improved result. And one more thing you have to emphasize over here, it is the adjusted R-square value. What it's meant for, it's explaining the explained variation of the data. This is meant for R-square. And what is explaining over here? Its maximum value can be 1. It's ranging from 0 to 1. This all information I have given in my prior slides to you. And in that slide, I mentioned that the R-square has to be varying from 0 to 1. So 0 to 1 starts, it's whenever it's closer to the 1, it's meant for a very good fit of your data. And whenever it's closer to the 0, then it's meant for a poor fit of the data through these explanatory variables. But here, approximately 87% of the variation through these two variables has been explained. So this is the best model as it's going towards the 1. So now I would like to go prior to my back slides. That was here. The hypothesis testing. Certainly I will cater your questions as well, and majority are catering over here. And it's again, somebody asked how to formulate the hypothesis. Hypothesis, my dear, is the assumption, is the idea, is the question in the mind of the researcher, is the postulate, which may or may not be true, and it can be the statement which the researcher believes to be true, but it may or may not do. So we need to test it out. Whenever a researcher in the field of study set out a theory, he or she first formulate a hypothesis. For example, being a teacher, I go into the class, first year class may I went, and I perceive and assume that on the average, the height of the student is 5.5. So this is my postulate. This is my assumption, which may or may not be true. So I need to test it out. This can be sometimes my claim. So it's the recruiter claims, which may or may not be true. So we need to test it through the hypothesis testing. Hypothesized value, it is maybe true or maybe not. So there can be, you can say, two states of to formulate the hypothesis completely In our one state, you have to formulate your H naught, which is the null hypothesis, usually having the equality, and nullify all the states as well as having the greater or lesser stance with the equality. And the H1 is known to be the alternative hypothesis. And this is usually known as to be the researcher hypothesis, because it's very critically explained that whatever you are saying, that I'm saying that on the average, the height is 5.5. But in as a researcher, when I would like to test it, I said, no, it's not. I can maybe say it's greater than, it's less than. So there is a rigid stance for that. You see? So it's a researcher hypothesis, which critically takes your equality values over there. I think it will be more explained when I will go for the steps for that. There are some basic ideas for this. One more thing needs to be clear, that we usually work for the sample data because the population data is not available majority of the times. So we usually go for the sample observations. In case of sample data, you have some population in your, in case of population data, you have the population, and the parameter means to be, which are defining the characteristics of your population, like the mean, the variance, the proportion, the difference, and these are the fixed quantities. This cannot be changed. So in hypothesis testing, you are formulating your hypothesis, your H0, your H1 for the entire population. But you see, the work on the sample data all the time means we have the sample data, we need to work on the sample data, we need to infer about the entire population. So that's why hypothesis testing comes into the inferential statistics. The univariate analysis is usually go for the descriptive statistics, which describe your data, and hypothesis testing is go for the inferential statistics, which needs to draw the inference on the basis of the sample data for the entire population. And the usual things we have it over here. Mean, these are the Greek letters. We utilize mu for the mean or average for the single population. If we have the two population, we can see the difference. We need to test their difference. If we have the proportion, so usually stands for P or pi into the books, and is the difference for that, as well as the variability is denoted by sigma square or sigma, and their ratio we can test it. Now, very quickly, just I have 5 minutes, so I will formulate you or about the how the steps over here. Steps are, first of all, you need to formulate. As I told you, this was my perception that on the average, this is on the average, not mean. On the average, the height of the student is 5.5. I can formulate over here. But somebody, being a researcher, when I tested out, I said, no, it's not. The first state is complete over here, equality and not equality. But this state, which is usually known as the two-sided hypothesis, is not giving us the clarity if we will accept our H1. After some steps, we will accept or reject our H0 or H1. So, for example, in this state, we will accept our H1. What you can perceive here, on the average, the height of the student is not 5.5. Then what it is? It is less. In the ambiguous states, you have it in the two-tailed testing. So that's why, being a researcher, we go for single tail test, which is more clear. It's a directional hypothesis. These two states are known as the directional hypothesis. Here you can say, on the average, the height of the student is greater than equals to. But being a researcher, I can say, no, it's not. That's it. I'm rigid in that to test it out. So it seems to be, if you accept your H1, so the height is not 5.5, it's certainly lesser than that. Here, it is certainly greater than that. So these are recommended usually, but anyhow, it's the first stage you can test for the two-tail as well, and then go for one by one for single tail test. So first of all, you need to formulate your hypothesis, H0, H1, either this state, H0, H1, either this state, H0, H1, either this state. So it is completing a one state. It किसी भी चीज को miss नहीं कर रहा. You see, If you have it lesser than and greater than stance in the H naught, then what is left it? The greater stance. It is a lesser than an equality stance here. So left it stance goes to the H1 greater than stance, and it is completing one state, one complete state over here. Similar here and similar here. So the second step is going to be the alpha. Whenever we start some research or testing, it's going to be all over. Whenever we have it such hypothesis testing, we have two sort of risk simultaneously working with us, which is known as the alpha and beta. Alpha is primarily needs to be decided. It is the probability of rejecting H naught when H naught is true. It is known as type 1 error. This is the error now. You are rejecting H naught when basically it is true. This line is known as given that. This is known as the conditional probability. The second stage over here is priorly known. Priorly known means this state is basically true. Whatever written, it is true for all the time. So it's going to be that H naught is true and we are rejecting it out. Oh, how comes? Like a person committed a person is basically innocent and the court trials because the evidence come against to him and judge conclude that he commits some error, means to say he punished. So what was the hypothesis? Basically, he was innocent, but we are rejecting it. And as this is the error, so this is known as type 1 error. So the probability of rejecting H naught when H naught is true. Again, I will explain. Like a person is innocent, but the evidence come against to him. What was the decision of the judge? Certainly, judge said he or she commit the error, some errors, some things which he has to be punished. So we rejecting the reality. So such errors are known to be type 1 error. Simple words में जब true state को सही चीज को आप गलत कहते हैं, that is known as the alpha. Fine. And beta is quite dangerous. This is known to be primarily you need to decide about the 1%, 5%, 10%. As this is the probability, so 10% probability mean 1 minus alpha is your confidence level. You are 90% confident in your work. Here you are 95% confident in your work. Here you are 99% confident in your work because there is just 1% error you committed for that. And we are human beings, certainly we can commit the error like the judge commit. So there are some steps, what the working behind these postulate. Usually for the mu testing, it is Z and T test working. You do not need to learn these formulas. These are already built into the SPSS and R. And as I show you these in the slides, the recorded slide, you have it already, how you can go for the proportion testing for single and double and the mu testing and T testing. So I think so these are already explained priorly, but these two states are working behind. So the question is that when to use Z and T? Here is the answer that usually we use for Z test. There is just one state on the basis of the sample size and the population variability. When sample size is small and the population variance is not known, then you have to go for T test. And you know, for the T test, even we have the assumption that the sample is come from the normal distribution. So for the large sample, it does not matter you use T or Z. But in the small sample, it does matter that you have to use your T statistics when your sample variability is not, population variance is or standard deviation is not unknown. Now the state is going to be critical vision. It's how to decide. Now these are the built-in function into your R and SPSS as well, and many software that you have the p-value as we have been discussing the regression. You got the p-value. If the p-value is less than 0.01, so what you need to do, then you need to accept your alternative hypothesis. Otherwise, the null hypothesis you need to accept. Fine. Otherwise, this has to be greater stance over here. I'm trying to be very quickly finish it up. Then we will discuss the question answer session. There's 2 more minutes I want to that. It's going to be tabulated value you can also use, but it's obsolete. you have the tables for the Z and T and proportion binomial tables, Poisson table, and for variability you have F statistics table. So many tables you have it over here. So you can utilize the table value as well if you don't need to check your p value. But I do recommend you can take the CN on the basis of your p value automatically. But if you want to go for tabulated value, so these are already expected for you, and you can also calculate these values from the table values. So this is all from, I think so, my side. And now I would like to address few questions. There was the question that what will happen when we have to apply the chi-square for the categorical and continuous variable. I pointed out you have to work for the point by serial correlation in that. So otherwise you have to make the categorical data, even though you have the quantitative data set like the age, but you need to present it into its categories. So for the two categorical data, your chi-square will be worked out, otherwise it will not work it out. And then there was a regression analysis question. I think so I have explained on hands-on formulation of the null and alternative. It's also discussed, and how to organize the hypothesis question is also addressed over there. And if any more questions you people have it, so I think so we can go for that. Gohar, please open the question answer sessions now, and I stop sharing here.
All right, ma'am. We have a question from Dr. Sobia Jameel. What is the difference between hypothesis and estimation?
My dear, hypothesis, again, I said this is this is the formulation of your assumption, right? You are assuming something or you need to test. Estimation is the tool and method in which you drive some formulation for your corresponding parameter. There are few estimation methods like the maximum likelihood estimation for that, for the population parameter. Whenever you have the sample data, then you can go for likelihood testing and regression estimation, so many other estimation, moment estimations. So these are the estimation method over here, and hypothesis is your assumption which you need to test it out. It's a statement, and then you need to test through some estimated process like Z and T is your formulation over there. G, my dear.
So you're all requested to please respond to the chat with your questions and comments. And meanwhile, I'll just launch the polling as well. You can respond to the polling. So, ma'am, we have another question from Rana Rabab Durrani. She's asking how to get the software SPSS.
My dear, SPSS first answers go for the Mr. Asif Shami. So that's why I deliberately skip it. But we can manage it by myself as well. But you have another session from Mr. Asif Shami entirely on SPSS. So I think so you may ask the question from him.
Thank you, ma'am. Then we have Dr. Mujtaba from Mehran University. Better to include type 2 error as well with example like you talked about type 1 error.
Okay. Yes, sir. There is the similar example we can proceed. Like, for example, somebody really commit some error or he or she do something wrong, right? But the court trials are again against, like perceiving that he or she is an innocent person. Got it? But in reality, he or she commits some error and not the innocent person. But the evidence goes against him, means said he or she is an innocent person. So what will a judge do? Certainly, kuch bhi nahi, nothing na, usko koi saza nahi hogi. So this is the type 2 error. When you have exclude such personalities or variable or objects which are really in the problematic state, but you said it's nothing. So this is the type 2 error. And type 2 error is directly related to the power of the test. power of the test will be reduced. It is denoted by beta. It is like H naught को आप accept कर रहे हैं जब H1 true है. Like this. This is the probability of accepting your H naught when given that H1 is true. So हम H1 को true नहीं मान रहे. Simple words में अगर हम किसी गलत इंसान को community में छोड़ देंगे, he or she commits some sin or error, so क्या होगा? Society में again it's certainly not be the beneficial for the society. So उसको punish करना चाहिए. So it is more dangerous, right? And it's directly related to the power of your test, whatever you are doing. That much beta jitna increase hoga, your power of the test will be decreased as it is the probabilistic relation. So 1 minus beta is your power of the test. So it's directly related to your power. Anything else, my dear?
Yes, ma'am, we have a lot of questions.
Yes.
Someone from university, Ms. Amber Sheikh from University of Education says, can we use software Mathematica by Wolfram to do statistical analysis?
Mathematica, yes, you can go for that, but it is, I do recommend use R for such descriptive and bivariate and sort of things, because Mathematica is more sophisticated. For example, you develop a quantile function and for newly developed distributions, and you do not have an idea how to get some built-in function over there in the R exponential distribution, binomial distribution, Poisson distribution, and you just write it up R norm and you get the normal distribution over there. But some newly developed distributions are not built-in function of the R and SPSS. So when you are in such states, so it's better to go for such sophisticated software. But certainly you can do descriptive analysis in Mathematica as well. But I do recommend use R or SPSS for such purposes.
Next, we have Ms. Amna Gul. She's a PhD scholar from Allama Iqbal Open University. If we are doing qualitative inductive research, is it recommended to use mini qualitative analysis?
Yes, my dear, qualitative, you can use such analysis in that, and with the different softwares. I have not much into the qualitative research, so that's why I do not need you guide much in that stream. But there are certainly sophisticated software for qualitative research as well. Yes, certainly. I have an idea that you can use this, whatever you studied over there.
Then we have a comment from Ms. Madiha Noor from the economics department. Thank you so much for such an informative session. Ms. Rehana John says, thank you for informative session. Dr. Subia has a question. In Pearson, is it necessary to have both quantitative parameters or rank categories would work?
MPS stands for, my dear. What do you mean by it?
PS, I am not sure if
Pearson correlation. Yes, for Pearson correlation, movement correlation, it is obligatory that the both variable has to be quantitative. Otherwise, not.
Thank you, ma'am. Dr. Atikur Rahman says it is helpful, Dr. Saiba. Thank you for the informative session. We have next Hassan Ali from Sakkar IB, a very informative session. Thank you. Thank you from Ms. Amber Sheikh, then Ms. Sonia Ghazal, then Ms. Subia. And again, we have a question from Dr. Mujtaba. Could we have implementation of any hypothesis test cases through R here, or it will be covered with interpretation in another session?
It can be, but my dear, you can see our recorded lecture, it's over there. And in the recorded lecture, I mentioned about the single mean testing, step by step with their interpretation, and the proportion testing, step by step with the single and double. So I think so you can go for that. It's over there in the recordings, which are priorly provided to you.
Next, we have a question from Hafiz Rukhsar from Allama Iqbal Open University. Ma'am, what book do you recommend for statistics for us? It should be comprehensive and easy.
My dear, at least for if you are a non-statistician person, so you can go for certainly graphical representation, univariate and bivariate analysis, not too tough. But whenever you are in the state to apply some multivariate techniques, So at least you need to concern some statistician. And certainly when you are planning or designing your hypothesis and how to select this sample, because this is the crucial thing. If you have the appropriate sample and sampling design, then you can get the valid results. So it's better to consult some statistician when you are planning to conduct your research. Because you see, somebody came to us from social science, I do not need to name them, इस पे logistic लगा दें, ठीक है? My dear, we need to check the assumptions. Like the simple linear regression model की assumption क्या है? That response variable have to follow the normal distribution. We need to check it out. If it's not normal, then some transformation we can do it. Logistic की क्या है आपके पास? Logit और logistic regression लगाने की क्या assumption है? That the response variable has to be binary. Means you need to check the relationship between the probability. आप probabilistic relation develop कर रहे होते हो response variable का with respect to the independent variables. And then there are so many other techniques. You can go for the ANOVA if you have such a categorical and continuous variable relationship, and other things certainly like this. And yes, I would like to comment on that. Somebody asked for the structural equation modeling, and it is beyond this session, but I can respond. Before structural equation modeling, you have to go for the factor analysis. From the factor analysis, you can get the latent variables. Latent variables are not the, you can say, true variable, which are containing the observed one. When you extract the latent variable, then you can apply the regression modeling on them for getting the structural equation. So structural equation modeling is such a comprehensive thing in the multivariate analysis, and it's demand priorly the factor analysis for that. Yes, anything else, my dear?
We have two new questions, and then a thank you from Dr. Adil. Great session, thank you. And then we have Asadullah. The university name of the university is not mentioned. He says, Madam, I have both qualitative and quantitative research courses and econometrics in upcoming semester. Could you please guide how I can prepare for them in advance?
Yes, my dear. Econometrics is usually go for, you see, regression. So simple, multiple, logistic, probit. I think so. There are the tutorials I do recommend, and these are very good tutorials over here. Why I'm recommending you R? Because R is a free software. There is no ethical issue for that. SPS is, if you will take pirated version, then there is ethical issues. It is a click get over there. But R is, I think, so free and more sophisticated software, and it's also using into the big data analysis. I would like to show you a bit essence of the big data if you will give me just 1 minute after that. Otherwise, I can show it to the next sessions anyhow. But I go for that. You can check the sessions free on the, I think so, YouTube's. You can get it and prepare for regression analysis. Make strong your understanding on regression. Then econometrics will be quite easier for you, I think. Yes, Gohar, anything else?
Yes, ma'am. We have a question from Dr. Mujtaba again. Please also explain for all if prior knowledge on association between two variables is meaningful before applying correlation test, or we can apply on any two variables, whether depending on each other or not.
Yes, whether depending or not, you can check their correlation. But prior knowledge is certainly a good essence. If you even though have no prior knowledge that the two variables are associated or not, you can check their association. So by the result, you can get they are associated or not. So I don't need to be so worried about that. I have no idea how they are associated. Can I check the association? Yes, of course you can check the association. But for the regression analysis, I do recommend that priorly you have an idea that which is your response variable and which are your explanatory variables.
Next, we have, do we have any expert of SEM and MOS software in Islamabad? I don't think so.
My dear, no idea. You can check it out with, I think so,
Last,
NAST,
we
because there was
just,
some, yes, yes,
sorry, we
yes,
just
yes,
moved
yes,
towards the
please.
last question from Miss Aisha. Kindly mention the session on regression.
Aisha, it was the simple and multiple linear regression with explanatory examples and hands-on videos already provided to you. If you see the lecture slides and the recorded lecture, I think so for the simple and multiple, you get a pretty good idea about that. So I think so you can go for those slides and recorded lectures. Otherwise, you can mail me, my dear. No problem.
Ma'am, at the end, Ms. Amber Sheikh is asking, could you please explain the Monte Carlo method?
Amber, it is the Monte Carlo method is a simulation study, my dear, and there are so many simulation studies. When you have the prior distribution of your variable, this is basically what you need to select this sample again and again from your respective big sample. And Monte Carlo is meant for when you have the distribution knowledge, then you apply the Monte Carlo simulation study. If you have no idea the distribution of your variable, then you go for the bootstrapping. So this is the main difference. Both are going for the simulation studies. So Monte Carlo is a simulation study in which you need to select, basically simple words, you need to select so many samples, thousands, lakh, 2 lakh, in order to get the distribution for that particular unknown statistic. Then you apply the Monte Carlo. Monte Carlo is the simulation study method. That's it, nothing else. A higher dimension programming is demanding for that, my dear. The essence is that the understanding is that whenever you have a prior knowledge about the distribution, so go for the Monte Carlo simulation. And whenever you do not know idea about the what is the distribution of my variable, then go for bootstrap simulation studies.
All right, ma'am, that's pretty much it. We have thank you from Miss Aisha, and then there is Miss Amber also thanking you for that. Thank you, Dr. Itrat, for taking out time for this session, such an informative session. Please note, dear all, please note that we'll be sending out the video recordings and the post-webinar material within the next 3 to 5 working days. And thank you so much, Dr. Itrat, once again.
Thanks a lot, my dear. Thank you very much, my dear participants. Okay, Gohar, if you would allow me, so I would like to show the power of R to my participants.
Yes,
just
ma'am.
within 1 minute. Nah?
Please do.
So, my dear, it is beyond that, whatever we have been discussed here. So R is really very sophisticated, you see. You can go for big data analysis, like there are so many built-in functions which are having thousands and thousands observation in that. Like we have a package here in the Mosaic data. It is a built-in package into the R. And into the Mosaic data, we have Saratoga houses data, which is having 1,700 and blah, blah observations. I'm just calling it out over here. You see, it's a blue one, so no problem. Then I'm putting the simple linear regression. You see the same command, linear model. Price is my what? Dependent variable, and these all are my independent variable. So it's over here. So it's again giving me what? The summary for that. And how many observations you have? You see, you have it here on the right side. You have listed the or the Saratoga. Look at here, 1,728 observation. You would like to see it, but kitna hai isme data, right? So we can view it even as well. Similar for the logistic regression. Somebody was asking. We have the Mosaic data again, Mosaic package, and CPS85, the built-in function package and built-in data set. We have it. So we can run it, and it's the GLM. GLM stands for generalized linear model, and with the family of binomial, as I told you, the response variable has to be followed binary 0, 1. So you are now checking the probabilistic relation. So it is over here, it's green and it's working, and you can also see its output here. So you do not need to put the data like labor work we have done, but for that you need some practice, and you can see the data over here. Look at there, the Saratoga houses data. It's having so many variables, so many observations. As I told you, it is the 1,790 something. So anything more over here, my dear, you can contact me in this regard. But certainly you need some practice, tutorial, and through my recorded lectures. Thank you very much for the session. Have a nice day. Thanks a lot.
Thank you, Dr. Itrat. We end the session now.
Thanks. Thank you.